warm welcome to all the viewers. Friends, in this video, I'm going to show you how you can work with Jamovi, which is a freely available software. You can utilize it for conducting covariance-based structural equation modeling. Along with that, you can use it for conducting all the functions which can be done in IBM SPSS software. So, in case you don't have the access to SPSS software because it's a licensed software, you can easily download Jamovi and start using it on your desktop. So this is a very user-friendly software to be used. So quickly let us start and learn the features, the important features of Jamovi. So first of all, we have to import the data. You click here on the left side and then you click on new. And when you click on new, there's a new sheet which has come up. In this new sheet, we have to import the data. So we click on open. And where is your data? Your data must be stored on Excel or CSV format. Many of the formats do work over here. So my data is here. I'll go to browse and then I have my data. You see here CSV format 305 is the respondent size in this data sheet. I click this and I import the data. You see, instantly the data has been imported from my CSV data sheet. And you see here, these are the case IDs. It's a data of 305 respondents. Let me explain to you. This is the way you can stretch this bar to see all your observed indicators over here. So, occupation 1 and 2 and 3. So, 1, 2, and 3. There are three categories of occupation over here. One is student, two is private job, and three is government job. Gender is 1 denotes male, 0 denotes female. So 0 and 1 denoting female and male respectively. Then food quality, I have four observed variables, FQ1, 2, 3, 4. All these observed variables in this data sheet have been marked upon 5-point Likert scale. Then you have service quality SQ1 to SQ4, four observed variables measuring service quality. All are reflective indicators. Then ambience AB1 to AB4, four observed variables measuring ambience. Then price fairness PF1 to PF4 and customer satisfaction CS1 to CS4. Now, this study assesses the effect of these four variables, that is food quality, service quality, ambience and price fairness upon customer satisfaction who is dining in a restaurant. All of them have been marked upon Likert 5-point scale. So this is how I imported the data. Now what to do? I can change the scale of the data by clicking over here. So when you double click, I double clicked on FQ1 and here you have the data variable FQ1 and measure type you see here. You can select with from nominal, ordinal or continuous, right? So since this is ordinal because it is measured on 1 to 5, you see the levels over here 1 to 5, Likert 5-point scale where 1 stands for strongly disagree, 3 for neutral and 5 for strongly agree. In case you have any missing values, you can enter over here. Otherwise, it's okay. You mark it as ordinal and it's done. So like this, we can move to FQ2. You just have to click on this right side arrow and it will take you to FQ2, which is the second observed variable. Again, we can make it as ordinal because it's on Likert 5-point scale. Like this, we can change all of them. So this is one of the features by which you can change the scale of the variables easily in Jamovi, right? Once you have done this, you have imported the data and checked the scale. What next needs to be done? Now you see here on the top, you have analysis bar. This is the data bar. This is the analysis bar. In analysis bar, you can see so many functions have been added. Whatever you want to do, you can add those modules. They are available over here. How they are accessible? You just have to click on this plus button and then you go to Jamovi library. And here when you type any of these names, say I want to do factor analysis. So type here factor. So you see here chi-square tools, chi-square analysis tools. This is installed, already installed. Then whatever is installed already by me, you can find over here, and what you need to install, you can type in here and get it installed immediately. Jamovi will immediately install it. Okay, so this is how you do it. Now, these all different functions, as you see here, structural equation modeling, path analysis is here, and you can also use R interface. So Jamovi has a backup of R interface. It works on R interface. So whatever calculations you are going to do, you can do it, and behind the scenes it runs R software to get you the metrics, to get you the calculations. Your data, first of all, in case it has missing values and exhibits non-normality as well, in that case you choose MLR, that is robust maximum likelihood estimation method, when you are doing structural equation modeling. Now this is mediation moderation, MED, MOD. You can see here GLM mediation model is also available. So general linear model is available, mediation is available, moderation is available, right? Linear models, you have GLM, LMM, GLM, and GLM, generalized mixed model, generalized linear model, linear mixed model, and general linear model. I've explained all these four models in my previous video. You like to go back and check on those videos. You will understand the concept of these four linear models and when to apply them, how to use it, why they are so useful. Then you have composite structural equation modeling, which works just like PLS SEM works. In case you have PLS SEM smart PLS software, that gives you much flexibility and much better results in terms of stability if you use PLS SEM, because Jamovi is basically meant for conducting covariance based structural equation modeling, similar to what you do in IBM SPSS MOS. Then you have chi-square factor analysis. So you see here we can do reliability analysis, principal component analysis, EFA and CFA over here, right? Then I have regression. I can do partial correlation, linear regression, linear multiple regression, and ANOVA I can do, t-test I can do, exploration. See, the first bar, exploration, gives you the descriptives, right? So in case you want to see the descriptives, let us try it out. I click on descriptives and this bar opens up. Now I want to check. Descriptives means the frequency, the mean, median, mode, right? So it means missing numbers, mean, median, standard deviation, minimum and maximum values. So if I want to check in for, say, occupation, so I put over here occupation variable. You see, instantly you get the results on the right side. 305 respondents are there. Mean is 1.55, which of course doesn't make any sense for nominal variables. Occupation is a nominal variable, so the mean does not make any sense. But still, I showed you a method how you can do it. The minimum is 1 and maximum is 3. Through this, we can check that there are no idle values being put up, deliberately being put up, or by mistake it has been put up in the data set. So by mistake there are no missing value, though no missing values. You see, missing values are 0, and the minimum and maximum level is appropriate, as we have three categories of occupation in our data set, 1, 2 and 3, right? So once you want to take it back, you can take it like this. Now I go to statistics. I want to find out the frequency, right? I want to find out the frequency of categorical variables, that is occupation and gender. I click on occupation, press the shift button and click on gender, and then push this right arrow. Occupation and gender both come over here, and I click on frequency tables. Once I click on frequency table, I'll get the counts. You see here occupation 1, 2 and 3 category. What is the counts? The percentage of total and cumulative percentage, and then I get it for gender as well. So this is the frequency table, right? In percentage and in counts you get the values. Now let us check out multiple linear regression, right? So I go on regression and linear regression, right? So in linear regression, I want the dependent variable as customer satisfaction and independent variables as price fairness, ambience, AB, service quality denoted by SQ, and food quality denoted by FQ. Now, these are the observed indicators, right? For linear regression, as we do it in SPSS also, first we have to transform them into a composite score. Composite score for food quality, composite score for service quality, ambience, price fairness, as well as for the dependent variable, that is customer satisfaction. Now, how to convert it into a composite score? So let us first convert it and then we'll come back over here for linear regression, right? If I want to create a computed variable over here, I go to compute, and when I click on compute, I have this variable x. I want to name it as FQ, that is food quality, right? Description, I can put whatever description I want to put, is equal to, just like SPSS, I can enter. So this is FQ1 plus FQ2 plus FQ3 plus FQ4, right? This is the formula I gave over here, and this has to be divided by 4, right? This entire has to be added up to get the mean score. That's how you do it in SPSS also, to get the composite score of ordinal variables and get it converted into a mean score, which can be taken in as a continuous variable for regression, right? So that is how I do it, and you got the score. You see here, instantly you got the score 2.75, 1.25. So this is the score which we got after adding up FQ1, 2, 3, 4 and dividing it by 4, because there are 4 variables. Similarly, I can do it for service quality, that is SQ. So SQ, so in brackets, SQ1 plus SQ2 plus SQ3 plus SQ4 divided by 4. So again, you see, you got the numbers over here. And now I want to do it for, let us do it for all 5 and then I'll show you. So now you see guys, I've got the 5 variables, 4 independent variables, 1, 2, 3, 4 on scale, because we have taken out the mean score of the observed variables to get the composite score of the variables. That's how you do it in SPSS also. And then you have customer satisfaction also computed as a mean score, which is our dependent variable. Now you can go and do the regression analysis. But before that, we must check in for normality of this data, right? So let us go to descriptives again and check the normality of the data. I need to go to analyze, exploration, descriptives. And now in descriptives, I'll put all my 5 study variables, including dependent and independent. And then I want to find out the skewness. You take here on skewness, kurtosis, frequency tables, and you see the results are generated in front of you immediately, so fast, right? So you see here, n is the number of respondents, missing values is zeros, mean of each of the variables, median, standard deviation, minimum score and maximum score, skewness 1.70, 1.06, 1.03, 0.899, 0.725. So we take that if the skewness is within -2 to +2, this range is quite acceptable for assuming that our data exhibits normality, and we can go ahead with parametric analysis, right? Standard error skewness, we got 0.10. So if you divide the skewness by standard error, you get the z-score. So that is for that purpose. Even you have it for kurtosis, you get the z-score after dividing kurtosis value with standard error of kurtosis, and kurtosis value which is recommended for assuming normality is -2 to +7. So these are all within the range of -2 to +7. So we are good to go as our data has clear the check of normality. The check of normality is done, which is a required assumption for multiple linear regression. Of course, there are other assumptions also, like independence, homoscedasticity, no multicollinearity, independence of observations. Yes, they are all independent of each other. But for here, I'm just showing you the functions of Jamovi and how to execute a simple multiple linear regression. Later on, we can do some other videos wherein I will explain how to check in all other assumptions as well, which are very much required for multiple linear regression, as well as some of them are required for conducting structural equation modeling as well. Assumptions are a very important part of analysis. So with skipping the assumptions, you are losing on essentials, which may jeopardize your results later on, which may affect your results later on if you don't check in for assumptions. So it is crucial to check the assumptions. Now I'll close this, and I'll close this, remove like this, and now I want to do regression, linear regression, all independent variables FQ, SQ, AB, and PF, they are continuous in nature. So I put them as covariates because they are continuous in nature, right? And customer satisfaction, I put independent variable. So once I have entered the dependent variable and the covariates, that is the continuous independent variables in my model, I got the linear regression results over here. You see simultaneously where R square is 0.210. That means 21% of variance in customer satisfaction is together explained by these four independent variables PF, AB, SQ, and FQ, right? If I see the path coefficients, model coefficients, so you see here that PF, the P value is 0.179, which is not significant, and the unstandardized estimate is 0.0796. T value is 1.35. This has to be either lesser than 1.96 or greater than plus 1.96 so that we can say it is a significant path and it is affecting significantly. It has a significant effect on the dependent variable. Similar for ambience, you see here the p value is less than 0.05, that is 0.001, less than 0.001, so it is significant, and as shown in by t value also this is greater than 1.96, right? Service quality 2.43 greater and p value is less than 0.105, again significant. Food quality, p value is greater than 0.05, so that means insignificant, and same is shown to us by t value also, t score also, which is 1.76, lesser than 1.96. So in this case we see that price fairness and food quality does not have a significant effect upon customer satisfaction, whereas ambience and service quality have a significant effect upon customer satisfaction, right? So this is how you can interpret the results of this linear regression. Now, if you want to check the assumptions, you can check the assumptions over here in this bar. You can have the normality test. So you see the normality test we can do, and normality test says that p value is less than 0.001, which has to be greater than 0.05 to establish normality using Shapiro-Wilk. But as we have not considered this Shapiro-Wilk estimation, as it is quite sensitive to the sample size and prescribed for sample sizes less than 50, we have assessed the normality directly through skewness and kurtosis value, and it deemed out to be acceptable in our case. Then we can also see QQ plot over here. So assessment of normality can be done through all of these things. And residual plots also we can see over here like this. And if you want to know the outliers, right? So we can check on Mahalanobis distance. Mahalanobis distance data summary, we got mean, median, standard deviation, minimum and maximum range, and participant below p-value threshold, that is below 0.001. So those below 0.001 are deemed to be outliers. So it has shown us clearly that participant number, respondent number 13, 21, 83, 118, and others, all of these are maybe they can be outliers, so you need to go back into your data and investigate whether they are outliers and whether you plan to remove it from your data set. In case you have a large data set, then it does not affect whether you remove the outliers, it will not affect your data. But if you have small data set, removing the outliers has to be done with quite considerable assessment. Before removing the outliers has to be done. Then Cook's distance, I can also see Cook's distance over here. Now we use Mahalanobis distance and Cook's distance to estimate the outliers. Mahalanobis for multivariate outliers and Cook's distance for influential outliers. The formula for calculating Cook's distance, estimating the Cook's distance influential outliers is you have a formula 4 divided by n. N is the sample size. So in this case 4 divided by 305 is 0.013. In case we have any values greater than 0.013, they can deem to be influential outliers. As in this case, you can see the maximum is 0.0795, which is of course greater than 0.013. So we can also check adjusted R square over here. So what does adjusted R square tell you over here? Adjusted R square considers only the significant predictor variables, which help to explain the variance in your dependent variable, that is customer satisfaction in this case. So as we see in these model coefficients, that price fairness does not affect the customer satisfaction significantly, and food quality also does not affect this. So seeing these model coefficients, we can assess that ambience and service quality have p-value less than 0.05. That means they are significant effect on dependent variable. Whereas price fairness and food quality have a p-value of greater than 0.05. That means they do not significantly affect the dependent variable, that is customer satisfaction. So removing their influence, we are just looking at the influential variables, the significant variables upon the dependent variable. So we get adjusted R square, which is of course lower than this R square, which was considering the effect of other insignificant variables also in the model. This is just considering the significant variables and giving us 0.200, which is the adjusted R square. It is lower than the R square. So this can be reported. This is a much reliable method to report your coefficient of determination. So friends, this was an introduction to Jamovi and how you can easily do linear regression, multiple linear regression in Jamovi. We can do further analysis, and further analysis I'll show you in the upcoming videos. So thanks for now, and do share it with your friends and faculty colleagues.